Okay, yeah, let's start. Okay, in the last class, we talked about the continuous random variable, and then what is a probability density function. Okay, uh, as we progress towards the chapter, we have to talk, or we are going to see what is a regression model. But before you actually go to the regression model, you need to know about what a correlation, what correlation actually means in case of two random variables. Okay, so correlation is kind of association that exists between two variables. So remember, correlation is always between two variables. Two. One is known as or you can plot one in x-axis, another one in the y-axis, as you can see it on the screen. For example, there may be any two variable. As you see it here on the screen, we are plotting, or one variable of in this example is a person's weight. Okay, so we plotting on the x-axis the weight of a person, and then on the y-axis that is your blood pressure. So do you think that there is a relationship between the weight and the blood pressure? That is how we are going to discover. So if there is a relationship that exists between weight and the blood pressure, it will be reflected if you find out the correlation. And in order to do it, you will have to plot these two variables, as you see it here, one in the x-axis, another one in the y-axis. So how many samples are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples are there. And all the samples, we are plotting it on a piece of paper. So from this plot, we can find out if there are any significant relationship or any association, that is a linear association that exists between a person's weight and his or her blood pressure. Okay, so the pattern of the data is indicative of the type of relationship. Sometimes there may be a relationship that exists. For example, if you think that if a person becomes heavier, then his blood pressure increases, that is a positive relationship. Or if it is the other way around, if you see that if the person becomes heavier, his blood pressure reduces, in that case it becomes a negative relationship. Or if there are at all no relationships between the person's weight and then its blood pressure, then it is also something that you can find from a correlation analysis. So regression analysis, or it's the next step, but the correlation study is somehow, it is before one step towards our regression analysis. But you do it in a correlation, you look into two variables, and then you try to see the association between these two variables. Okay, for example, the one that we have shown before. And then in a regression analysis, further, it can be more than two variables that sometimes you take into account. So in that case, a regression analysis actually tries to explore the relationship between two variables, or you can say a quantitative response variable, and the other one we term it as more of an explanatory variable. Okay. From the previous example, there is again, this is a relationship study, as you see it here on the screen. If it is a positive relationship, that means anything that increases in the x-axis, the y-axis value also will increase. So here on the left side, you see, suppose for example, you are taking the sample from 10 different students. Then you are asking the students how many hours you have spent really on your studies. And then when you finally look into the grades that the student achieves, you will see a positive relationship between. That means the number of hours spent in the study is directly proportional to the grades that the students achieve, the final grade. So in that case, one increases along the x-axis, the other one also increases along the y-axis. So in that case, you can say that there is a positive relationship between these two variables. Okay. Then there may be a negative relationship. For example, if you have a car and then you are using the car for 1 year, or you are using the car for 2 or 3 or 4, 5 or 10 years, then some parts of the car may get damaged, and in that case it will have a reduced reliability. So if you are using a car and you are not really changing the oil filter, or maybe you are not changing the clutch cable for a long time, maybe the reliability of the car will go down, because over the years it will go or undergo a lot of wear and tear. So the more the age of the car is, the reduce will be the value of the reliability of that car. So in that case, there is also a relationship, but that relationship is a negative relationship. Okay, so that is somehow you see it here on the screen in the middle. And there may be something which do not have two variables which have no relationship at all. For example, there may be a pulse rate and then the weight. So if you think that if the pulse rate of a person is between 90 and 100, or the pulse rate is between 60 and 70, then knowing the pulse rate, you can find some answer to his weight or her weight. So if we try to plot these two variables in a scatter plot, this is known as a scatter plot, then you will see that there is no significant pattern, or either a positive relationship or a negative relationship, but these points are scattered in a random manner in the whole scatter plot. So in that case, you can say there is no significant relationship between these two variables. So it can be either a positive relationship or a negative relationship, or there may be no relationship at all. But how much is the relationship in terms of quantity? How we do quantify the relationship? In order to measure that, there is one value which is known as the correlation coefficient, or which is denoted by R. Okay, so it measures the strength and direction of the relationship between the two variables. How is R calculated? R is calculated by the formula that you see on the screen. That is summation of x and y minus summation of x multiplied by summation of y, then divided by that formula. So summation represents all the sums of x. The x means a variable that is you are plotting in the x-axis, and the y is another variable that you are plotting in the y-axis. These are the individual values. Okay, and when you find out r, ultimately the r will lie between -1 and +1. So if the r is -1, that means it has a perfect 100% negative relationship. If it is +1, it means that it has a perfect 100% positive relationship. That means if your weight, you increase it by 1 unit, then your blood pressure will also increase by 1 unit. Okay, whatever may be the units in these two cases. So if it is true for all the samples that you are collecting, then you have a perfect positive or negative relationship. So, but that doesn't happen normally in all the situations. It lies between the values of -1 and +1. Remember, like for NDVI, it also changes from -1 and +1. So somehow, if the value is towards 0, okay, so if the value is towards 0, then you can say that there are no relationship, or the relationship becoming weaker and weaker. Yeah, excuse me for a minute, okay, I'm coming. Okay. Okay, let's start again. You all hear me? Do you? Hello?
Yes, sir.
Okay. So if the relationship is having a value of r, which is uh, from 0.8 and more, then you can say it has a very strong relationship. Okay. So if it is between zero point 0.6 to 0.8, you can say it may be moderately strong. Between 0.3 to 0.5, you have a fair relationship, and then if it is less than 0.3, you can say it is a poor relationship. Okay. So in that case, what is a regression then? So it is a statistical tool. I mean, regression is a tool that is used to investigate the dependence of one variable with one or more variables. So in case of correlation, you have two variables, but in case of a regression, you may have more than two variables. So, but remember always in case of a regression, you have one which is known as a dependent variable, and then you have the other one which is known as an independent variable. So, for example, if you are having a lot of rainfall, then maybe it will translate into flooding. So, in that case, flooding is dependent on rainfall. So, rainfall is the independent variable, and then flood is the dependent variable. Okay. Like regression or like correlation also. So you can say in that case we have two variables which is dependent and one is independent. But if you think of another one variable, okay, initial moisture content of the soil plus the rainfall affects the flooding. So in that case we have three variables. One is your initial moisture content of the soil. The second variable may be the amount of rainfall, and then the third one is the extent of flooding. So in that case, your extent of flooding is the dependent variable, whereas your rainfall amount or the initial soil moisture may be the independent variables. So regression, you may have more than one variable. If it is having more than one variable, it is known as multiple regression. If it is just one single variable, you have this uh, single relation or regression. So the dependent variable is known as, normally it is plotted along the y-axis, and then the independent variable is plotted against the x-axis. So when you plot these two values, and then you can fit a straight line, okay, the kind of line that you see it on the screen, and then from the slope you can say that either the relationship or the regression is positive or negative, or you at all have no relationship between these two variables. So the left hand side of the screen, when you have a negative slope, that means once your x increases, your y decreases. Then you have a positive relationship. Once your x increases, y also starts to increase. And then the other one is known as a no relationship. When you have x increasing, there is no change in the value of y. Okay? And these are the three conditions. So there are some terms which are known or you should know in case of a linear regression, or this is known as a linear regression model. That means when you fit a straight line into the data set that you plot. So as you know that the equation of a straight line is y is equal to a plus bx. So in this case, this is the equation. What is y? Y is our dependent variable which is normally plotted in or along the y-axis. X is the independent variable. So any value along x is a small x, any value along y is a small y. And then we have one value which is known as a or intercept, that is the initial value of y when x is 0. And then you have b, which is the slope. So these are the four parameters, or these are the parameters which are normally constituent of a straight line. So you can find out how b or a can be calculated using the equation that you have seen here on the screen below. So b is equal to That is summation of x into y, how many times? N times, minus summation of x multiplied by summation of y, and then it divides by whole thing. X squared, that is the sum, minus x squared, that is not the sum, and then you have n number of values. And then similarly you can find out a, that is the intercept, by y bar minus b into x bar. So what is y bar and x bar? These are again described here in the equation. So there may be some changes of a, or there may be some changes of b depending on different straight lines. Okay, and then either the slope can be positive or negative depending on the relationship. So this is a simple regression or linear regression model. Okay, so again there may be some other models which you can fit into the model, which is, you think if the relationship is not really a straight line, then you can go for an exponential fitting of the model, or it can be a logarithmic fitting of that simply uses different kinds of equations in order to fit into the two variables. One is a dependent variable, another one is the independent variable. Okay, so that is all about our regression, and then our fittings, and then your correlationship. But these things you have to actually apply it into the physical world in order to have a better understanding. Okay, so you have to keep on thinking. So you have to think in terms of some physical parameters. So if you think that there are some relationships that do exist between two variables that you pick up randomly, for example, if I say that the amount of food that a person takes has a direct relationship with the number of grade that he gets in, or he or she gets in examination. So if you try to measure these two relationships, you can plot one as a dependent variable in x-axis, another one as an independent variable in the y-axis, and then you can try to find out the relationship in terms of the r value. Okay, so sometimes you may get a stronger relationship, sometimes you may not get a stronger relationship. So these things you keep on observing, the things that you think there are because of cause and effect in nature. So then coming to one very important subchapter, which is known as the Thiessen polygon. So Thiessen polygon is an approach in order to distribute some values, which is more likely some point values inside a polygon. Okay, for example, if you look into this diagram, then the red colors thing that you see on the polygon is actually supposed, you can think it in terms of a watershed. Okay, watershed or any polygon area, and then you have three dots, P1, P2 and P3, which are the rainfall stations that measure the rain or the amount of rain that happens within the watershed for a suppose historical period of time. So there are some stations maybe at P1, then there is another station at P2 and another station at P3, which is recording rainfall data. So rainfall data means how much of a rainfall has occurred in P1, how much of a rainfall has occurred in P2 or in P3 for the last suppose 10 years. So in case of GIS, when you want to distribute the average amount of rainfall over this sub-basin or the basin or the watershed, then you have an approach which is actually formulated or proposed by this person. Wait a minute. This person known as A.H. Thiessen. So that was quite ago, long ago in 1911. That means some point data. If you want to distribute the values of some point data over a polygon. So in this case, what is our point data? Our point data is these rainfall values in P1, P2 and P3, and the polygon is the watershed that you see it here. And then if you want to distribute in such a way that you have an average value. So in that case, Thyssen polygon method is proposed by him, or proposed nowadays also used, and then it becomes a part of the standard GIS package in almost all the softwares. So it is not only used in GIS, it is also used in other fields such as geography, computer science, and then it has a larger application in watershed management or even in hydrology, particularly if you are using some flood modeling or rainfall analysis. Okay. The major application of Thyssen polygon is also in one subfield of geography that is known as human geography. And in order to know, to delineate the dominant regions or service areas for point data, such as stores or hospitals. So, for example, you can think it an example in this way that you have a hospital here at P1, you have another hospital at P2, and another third hospital at P3, and then there are people who are distributed within this red color, suppose a district. Then what is the likelihood that P1 is serving a person who is somewhere within the district? Okay, or what is the dominance of that hospital for a particular population who are inhabitant within that, inhabitant in some part of the district? So, which is a dominant service provider? In this case, it is a hospital, or it may be a bus station or something like that. So, but but after that, then what I actually wanted to know how to construct a Thyssen polygon. So this is the methodology is known as a Thyssen polygon method, and then in GIS also, this is the methodology that is normally followed. So suppose you have 3 points here, like the one that I show you in this diagram, and then you have a watershed, okay, that is covered by the polygon that you see on the screen. You have 3 points A, B, C. Then what you do, you connect straight lines from A to B, B to C, C to A. That is shown as step 2. And then you try to find out the middle point of these straight lines, and from the middle point of these straight lines you bisect that line, and then you extend that line to the outer edge of the polygon. So that is shown in step 3. So when you extend that to the outer edge of the polygon in step 3, and you try to, it becomes easier for you to mark the dominant regions for the particular stations or particular points. Either it can be A, B, or C. How do you mark it? So you just see it in step 4. Point A has a dominant region that is shown by the blue color here. Right? From point A to point B, if you consider only these 2 points, this is the bisector, okay? And then from point A to point C, the lower half is the bisector. And then if you just take all those 3 points, you can find out the dominant regions, okay, that is shown exactly with the blue color. So this is a Thyssen polygon method that has been undertaken to find out the dominant regions for point A, point B, and point C. So once you have found out these regions, then it becomes easier for us to calculate, in case of a rainfall, what is the average rainfall, or what is known as the areal average, using the Thyssen polygon method. So ultimately in the equation that you see, point number 5, it says the areal average is P bar, which is 1 upon A. A is the area of the polygon, and then the summation of individual point values, that is P1 into A1. And then in this case you have this example where P1 is 10 millimeter rainfall occurring, and then A1 is 12 kilometer square, and then P2 is 20, A2 is 15, P3 is 30, A3 is 20. Then you add those values on as the numerator, and then divide it by A, that is the total area of A1, A2, and A3. ultimately you get 20.7 millimeter. Then you can use this value as an average value of rainfall that has happened on a particular day, and then you can use it for your purpose of flood modeling or maybe for other hydrological applications. Okay. Then coming back again or coming forward in a way, we have talked about the relationships, then we have talked about regression modeling. So quite importantly or quite increasingly, sometimes you have to find out the values for a particular x. What will be the value for what will be the value of y for a particular value of x? In this case, remember we have fit a straight line with the observed points. So there may be many points, and then you fit a straight line with an equation of a is equal to b plus cx or whatever, and then you use this equation to know the unknown value of y once the value of x is known. So this is a method known as interpolation. Remember, interpolation is always done between two known values. In this case, we have two known values between the two extreme ends of 9 and 10. Okay? And between 9 and 10, there is a line that is being fitted, and then it goes beyond 9 and 10. But we are interested to know the value of a particular y for a certain amount of x, okay, that is shown by the red color. So the technique that is used is known as interpolation. It is quite commonly used technique. So interpolation is the statistical method by which related known values are used to estimate an unknown. So in this case, what are the related known values? We know the value of in 9, what is the value of x and what is the value of y. In point number 10 also we know what is the value of x and what is the value of y. But in the red color, we only know the value of x, but we don't know the value of y. So then you use the interpolation technique. So it is achieved by using other established values that are located in sequence with the unknown value. So sequence means your relationship, and then from the relationship you have a straight line that you have drawn and formulated that straight line, and using the straight line you can find out. For an example, okay, from thermodynamics, okay, this is some value that we are using in order to know. I'll give you an example of interpolation. So on the x-axis, you see here, you are plotting these values 1.0006, 1.0067, 1.0280, and ultimately the last value that you have plotted here is 1.898. Okay, and then corresponding y values are also you have found to be how much here on the screen. And it, yeah, 200, as you see, then 220. So if you look at the lower section of the table, you have plotted values corresponding to these two numbers, 200, 1.1555, and 220, 1.1898. Okay. So the question is, if you fit a straight line here, what will be the value of x for a particular value of y, or what will be the value of y for a particular value of x? So in this case, we have a value of known y, which is 212. Then you have to find out what would be the value of x. So you use this similarity of triangles. You take the smaller triangle, and then you take the bigger triangle, and then from there you formulate these equation, and then ultimately you can find out x. So in this case, our x is 1.17608. So this is an example of interpolated value. Okay. So why interpolation is necessary to know? Interpolation is the basis of one technique which is quite frequently used in GIS, that is known as IDW, or it is also known as inverse distance weighted interpolation. So far we have done interpolation in a two-dimensional field, okay, that we are only talking about a straight line here, right? But there may be values where you have to use interpolation of a surface. So for example, you imagine this as on the screen as you see here. This may be some of the concentration values of a certain chemical. Okay, maybe here it is 8, in this place it is 10, in this place it is 15 and 14. So all these points are distributed over a surface on the art. And then you would like to know what would be the value exactly at this square box. Okay, so in this case we may use IDW, which is an interpolation of a surface. So how do you do it? We do the kind of interpolation, but the theory behind this is that we try to find out the distance of this unknown point from the existing known values. Okay, so in this case, only as you see it on the right hand side, from the point number 10 to this unknown, this is the shortest distance. So if you have the shortest distance, then we say that this whatever value we have at this point is the one that is going to have a maximum effect to determine what would be the unknown at this question mark point. So the longer is the distance of the point from the unknown, its effect on this unknown will diminish, or its effect on the unknown will gradually reduce. Okay, so this is the principle of IDW. So that means where we have 10 here, it is the nearest, and then it will have the maximum effect. So if you plot this along a car, along x-axis, that is the distance, and then along the y-axis, the inverse distance values 1 upon d, then you will see that at the point 1 you have the maximum effect. Okay, then if you were following it along the 1 by d line, then at half of the distance or twice the distance at 0.2 meter, it will have 50% of influence, that's 0.5. Then another 1 unit distance more, that is distance 3, this will be somewhere here. So you can either take this graph, which is denoted by 1 upon d, or you can square the value of d, and then so you can plot the values. So that means the higher the distance of a particular point from the unknown, its influence to affect this unknown will reduce, and then this reduction is as according you show it in these two graphs. So how fast the weight decreases with distance is either you are using 1 by d or 1 by d square, that will determine. So that is how it is, why it is known as inverse distance weight. That means the weight is inversely proportional to the distance, and then ultimately you can find out the weight here. So how do you find out the weight? Weight at the point unknown is somehow given by the equation 1 by d divided by all the summation of 1 by d, and then that is each of the weights. So when you have a distance of 4, then 1 by d is 0.25, and then the weight is calculated by 1 by d divided by 0.25 plus 0.5 plus 0.33 plus 0.3, that is 0.28. So if you divide 0.25 by 1.28, you get 0.19. Okay, so once you get this individual weights, so this is the weight. So how much is the weight of this point? That is point number 15. In order to determine this unknown, you have a weight of 2.9. Similarly, When the distance is shorter, the weight is higher and vice versa. So ultimately you will get the weighted value, which is known as, which actually we are interested to find. In this case, this is 11.1 as at the formula here. And multiply 0.25 into 1.19 is 2.9, 0.5 into 0.39, it's 3.9, 0.33 into 0.26, all these values, then we add it up. So we get the unknown as 11.1. So this is also a kind of interpolation, but this interpolation is mostly done in case of a surface. So here you see the result. Okay? So these are the points or points. Yeah? You don't hear me? So somewhere in these points, you are using the IDW method in order to know. So these points had values, individual values, but ultimately you are using IDW to interpolate the surface. And then on all the points on the surface, you are getting these individual values. So next is the kriging. Kriging is something similar with interpolation, but I will not go too much depth into the kriging. It is a little bit complicated than IDW, but remember when IDW is a deterministic interpolation of a surface, kriging is somehow a uh, probabilistic approach of interpolation. And kriging is also affected not only by the distance from the unknown, it is also affected by one thing which is known as autocorrelation or spatial arrangement of empirical observations. Okay, so ultimately kriging, for the time being, you remember as kriging is another technique of interpolation which is probabilistic. Okay, so this is for the time being, and I will stop here for today. And then, if you have any questions, you can please throw the questions of this lecture today. Anybody? No? No question? Okay, then I'll stop here. Then I will take one more class to finish the syllabus, and probably I will. Maybe it is. I'll prefer it to be on Saturday. Do you have any exams or something on Saturday? When is the favorable time? Please tell me, because now I can see someone is saying we have a class exam now, computer science. Whereas I proposed the time in the morning, you should have told me in the morning itself, and I could have just rescheduled it. And for those people, I will share the video in the group. So, last class will be somewhere on Saturday, this Saturday. Okay? You have some busy schedule on Saturday or what? That is, Saturday will be 22. Today is 20. Oh, Saturday, I don't know. Let me see. It may be on Saturday, but Saturday even towards the evening time, I'll be able to tell. Okay, so just assume it to be around
Okay, sir.
4 to 5 o'clock on Saturday. Okay? Okay, then I'll share you the video.